Hello students, welcome to the another session of Fundamentals of the Analysis of Algorithms Efficiency, Unit 2 of the subject Design and Analysis of Algorithm. In this session, we are going to study about the mathematical analysis of non-recursive algorithms, and also we are going to find the time efficiency of illustrative algorithms. For example, algorithm to find the largest element in an array, and also algorithm for element uniqueness of an array. Before going to the mathematical analysis, we need to memorize the basic efficiency classes. So we shall have a glimpse on the basic efficiency classes. So here you can see some of the basic efficiency classes listed out. Basic efficiency classes is nothing but the mathematical representation of the time efficiency of any of the algorithm. Class 1, called constant, used to represent the scanning of array elements. Log n, logarithmic, used to represent the performance of the algorithm binary search. N, called linear, used to represent the performance of the algorithm sequential search. Similarly, n log n, called linear logarithmic, used to represent the performance of the algorithms merge sort and quick sort. N square, called quadratic, used to represent the matrix elements scanning. N cube, called cubic, used to represent the algorithms performing matrix multiplication. 2n, called exponential, used to represent the performance of the algorithm where the algorithm which generates all subset of n array elements. Finally, n factorial, called factorial, used to represent the performance of the algorithm which generates all possible permutations. Now we can go through with the mathematical analysis of non-recursive algorithm. Mathematical analysis means it's a mathematical representation of the time complexity of any of the algorithm. And as you know, we have two types of algorithms, recursive and non-recursive. Non-recursive, the algorithm which do not call itself repeatedly, is called non-recursive algorithms. The algorithms which call itself repeatedly n times until certain condition is met is called recursive algorithm. So now coming to this session, here we systematically apply the general plan for analyzing the time efficiency of non-recursive algorithms. And this plan tells us the principal steps typically taken in analyzing such algorithms. So here is a general plan for analyzing the time efficiency of non-recursive algorithms. In the step 1, we decide the input size based on parameter n. In the second step, we identify the basic operation of the algorithm. Basic operation means the output depends on the operation which is used in the algorithm and which is called repeatedly in the algorithm, is called basic operation. In the third step, we check how many times the basic operation is executed in the algorithm. Then we find whether the execution of the basic operation depends upon the size of n. If it is so, then we determine worst, average and best cases of the input of the size n. If the basic operation execution do not depend upon the input size and it depends on some additional properties, then the worst case, average case and the best case has to be analyzed separately. In the fourth step, we set up a sum for the number of times the algorithm's basic operation is executed. For example, C of n is equal to sigma 1, where I takes the value 1 to n. That means, so we have a for loop in the algorithm and that basic operation is executed in the for loop exactly once at each iteration. Okay. Finally, in the fifth step, we simplify such formula using standard formulas and rules. Then we get the exact time efficiency of the algorithm, which can be represented in terms of asymptotic notations, as you know, that is theta notation, big O notation and omega notation. So now we can go for the first example, so to which we are going to find the time efficiency. Before finding the time efficiency, first we shall look upon the algorithm. Algorithm is to find the largest element in an array of n elements. Here the algorithm name is MaxElement and the parameters are a of 0 to n minus 1. This algorithm is designed to find the largest element in an given array. And the input of this algorithm is an array of size n of set of real numbers. The output of this algorithm is the largest element in the array A. Initially, we initialize the variant max underscore value with the first element. Then we enter to the for loop where I takes the value from 1 to n minus 1. When I is equal to 1, so we compare the second element with the first element stored in max underscore value. If the second element is greater than the first element, then the second element is stored in max underscore value. Then loop repeats, I is incremented to 2. Now the third element is compared with max underscore value. If third element is greater, then it is stored in max underscore value. Similarly, for loop repeats for all n elements. When we come out of the for loop, so max underscore value variable consists of the largest element found in the array A. So this is the algorithm. Now we can find the time analysis for this algorithm. As we know, in the first step, we identify the input size n. In the step 2, so we determine the basic operation. Here the basic operation is comparison. So which is given by the statement if a of I greater than max underscore value in the algorithm. In the step 3, now we count the number of times the basic operation is executed. Since in the for loop exactly once the comparison operation is executed at each iteration. Therefore the basic operation comparison is executed n minus 1 number of times. Since your n takes or I takes the value from 1 to n minus 1. And in this fourth step, we identify the sum of comparisons as C of n. Now in the fifth step, we reduce the formula as C of n is equal to sigma of 1, where I takes the value from 1 to n minus 1, which is equal to n minus 1, where n minus 1 is nearly equal to n. Therefore, we can consider it as an average case, and it can be denoted using theta notation. Thus, the efficiency of the above algorithm is theta of n. Yes, it is theta of n. Now, we shall move on to the second example, that is algorithm to find the element uniqueness in an given set of array n. Here the algorithm name is unique elements with the parameters a of 0 to n minus 1. This algorithm is designed to identify whether all the elements of the array are unique or not. And the input of this algorithm is an array of size n. And output of this algorithm is true if all the elements of the array are unique, then it returns us true value. Otherwise, if any of the elements are repeated, then it returns false value. Here in this algorithm, we have nested for loops. The outer for loop is ith loop, where I takes the value from 0 to n minus 2. And the inner loop is jth loop, where j takes the value from I plus 1 to n minus 1. Here the a of ith element, that is ith element, is compared with jth element. The first element is compared with the remaining all other n minus 1 number of elements. If any of the element is found similar, then it returns us false. Otherwise, the I value increments and the second element is compared with the remaining all other elements except the first element. And in this comparison, if any of the element is found similar, then it returns as false. Otherwise, again the I value is incremented. In this way, all the elements are compared with each other. If any of the elements are found similar, it returns false. Otherwise, it returns as true value. That means we doesn't have any similar elements in the array. That means the array elements are distinct. This is your algorithm. Now we can find the time efficiency for this algorithm. So by applying the general plan, in the first step we identify the input. Here the input size is n, that is total number of array elements. In the step 2, we identify the basic operation, that is comparison operation. This is done in the algorithm by using the statement if A of I is equal to A of j. In the step 3, number of comparisons is counted. Since we have two for loops, I takes the value from 0 to n minus 2 and j takes the value from I plus 1 to n minus 1. Therefore, the number of times the comparison is executed is given by n minus 1 into n minus 2. So this can be the worst case of the algorithm. Then in the step 4, we represent C of n as the sum of comparisons. Finally, so this can be represented using a theta notation. Before representing with a theta notation, we need to simplify the formula as C worst of n is equal to sigma I equal to 0 to n minus 1, sigma of 1, where j is equal to I plus 1 to n minus 1. The inner sigma can be reduced as n minus 1 minus I plus 1 plus 1, which is equal to sigma of n minus 1 minus I, where I is equal to 0 to n minus 1. By reducing the outer sigma, we get n minus 1 plus n minus 2 plus n minus 3, so on till 1, which can be reduced as n into n minus 1 divided by 2 by using the standard formulas, which by multiplying n, which is equal to n square minus n divided by 2. This n square minus n divided by 2, which is nearly equal to n square. Therefore, C of n can be equated to theta of n square. Hence, the efficiency of the above algorithm is theta of n square for all comparisons of n into n minus 1 divided by 2 distinct pairs of its n elements. So this is the time efficiency. In this way, by applying the general plan of mathematical analysis, so we can identify the time efficiency for any of the non-recursive algorithms. I hope you had understood. Now we shall move on to the next session, that is MCQ session. This is just to know how much you had understood. So now we shall have the multiple choice question here. The first question is, what is the name of this basic efficiency class? Log n. Whether it is a constant or a linear or logarithmic, otherwise linear logarithmic. Yes, it is logarithmic. Yes, you need to memorize the basic efficiency classes, what we had tabulated. Okay. Now, second question is, what is the name of this basic efficiency class n cube? Can anybody tell me whether it is a factorial, linear, or quadratic, or cubic? Yes, it is cubic. We shall move to the next question. So this question is on the types of your algorithms. Algorithm with looping statements which do not call by itself is called as dash. Whether we are going to call it as non-recursive algorithms, recursive algorithms, or largest element algorithm, or we call it as just an algorithm. Yes, it belongs to non-recursive algorithm. We have two types of algorithm, recursive and non-recursive. It is a non-recursive algorithm. Next question. Algorithm which calls itself repeatedly n times until some condition occurs is called as dash. Do you call it as binary search algorithm, recursive algorithm, non-recursive algorithm, or a factorial algorithm? Yes, exactly. It is recursive algorithm. Next question. What is the time complexity of the algorithm? Largest element. So we had gone through with the time efficiencies of two algorithms, that is largest element algorithm and element uniqueness algorithm. Now, what is the time efficiency of the algorithm largest element? Whether it is n square, theta of n, or theta of n square. Yes, it is theta of n. Next, which is the basic operation identified in the algorithm largest element? Whether it is assignment operation, addition operation, incrementation operation, or a comparison operation. Yes, it is exactly a comparison operation. You are right. Now, we shall move to the next question. What is the time complexity of the algorithm element uniqueness problem? Please recall the session. What is the time complexity of the algorithm element uniqueness problem? Whether it is log n square, theta of n, or theta of n square. Yes, exactly, it is theta of n square. It is a worst case efficiency, right? Yes. Now the next question. Which is the basic operation identified in the algorithm for uniqueness element problem? Comparison operation, addition operation, incrementation operation, or an assignment operation? Yes, it is exactly again it is comparison operation. Here we are going to compare each and every element with the remaining all other elements, right? Now, the next question. Why the time complexity of the algorithm for element uniqueness problem it increments to n square? You had to give the reason why the time complexity of element uniqueness algorithm is increased to theta of n square. Okay. For choice 1, since we have nested for loops in the algorithm. Second choice, since we have n array elements as input, or it is a straightforward approach. So this algorithm has been written in straightforward approach. Okay. 4 choices, since algorithm do not contain any product multiplication. Yes, what is your answer? Yes, it is. Since we have nested for loops in the algorithm, that is ith loop and the jth loop. Okay. Now, the last question of this session. The sum function sigma of n is equal to theta of n is equal to sigma of I is equal to 0 to n minus 2, sigma of j is equal to I plus 1 till n minus 1 of 1 is identified for dash algorithm. So in the fourth step, we determine the sum of basic operations, right? So in we had studied two algorithms. In those two algorithms, in which algorithm we determine this function, whether it is largest element algorithm or algorithm for element uniqueness problem or algorithm for matrix multiplication, or it is algorithm for smallest element. Yes, exactly, it is algorithm for element uniqueness problem. Since we have two for loops, so we have two sigmas, that is sigma I is equal to 0 to n minus 1 and sigma j is equal to I plus 1 to n minus 1. So this is about this session. In this session we had studied about the mathematical analysis of non-recursive algorithms, and also we identified the time complexity for largest element algorithm and also algorithm for element uniqueness problem. And we had a recap on the basic efficiency classes also. And these are the references which we use for our references, that is to make the study materials and the PPTs. So first of all we had used the textbook, that is Introduction to the Design and Analysis of Algorithm, written by Anany Levitin. So this Anany Levitin book is a best book, what I can call it, for design and analysis of algorithm. Similarly, Design and Analysis of Algorithm, written by S.Nandagopalan, the Indian author, and also book written by A.A.Puntambekar. You can refer either of the books. All the books are very simple to refer. So that's it for this session. Thank you all. And this is our team for the LMS. And if you have any feedbacks, suggestions, please you can mail it us to the mail ID lms.dtech@gmail.com. Thank you again.